Hi everybody, it's Dr. Nigro. I wanted to walk you through a calorimetry problem where we're determining the delta H for a reaction. All right, for my example, we're going to be looking at the dissolving of sodium iodide. So we have 25.7 grams of sodium iodide that we're dissolving in 80 grams of water inside a calorimeter. We monitor the temperature change of the water and see that it moves from 20.5 degrees Celsius to 24.4 degrees Celsius. So the first question is the dissolving of sodium iodide endo or exothermic? To determine that, we have to look at what happens to the temperature of the water. And we see that it increases, which tells me the water is absorbing that energy. Well, where did that energy come from, you say? Well, it came from the reaction. So here the reaction is exothermic. And we know this because the temperature, I always spell this word wrong, of the water is increasing, meaning the water is absorbing energy from the reaction. All right, so with this in mind, we know that our delta H value is going to have to be negative. All right, but before we can calculate what the delta H is going to be, we need to know, well, how much energy is the water absorbing? So to calculate that, we use our formula for Q, where Q is going to be equal to the mass of the water times the specific heat capacity of the water times the change in the temperature. So just say dT. Right. So for this particular process, the water has a mass of 80 grams. All right. And I've had a couple of people ask me why I don't just add the 25.7 to the 80. Right. The reason is the specific heat, 4.184 joules divided by grams degrees Celsius, is for pure water. And if I add in that sodium iodide mass, now I have a solution or a mixture which has a different specific heat. So we need to keep water all by itself. All right. And last, we need to know the change in the temperature. Well, if we look, it went from 20.5 up to 24.4, which gives us a temperature change of 3.9 degrees Celsius. So we plug our numbers in, do our math, and what we find is a positive energy transmission of 1,300 joules. Right, now, in terms of the reaction, Q for the reaction is going to be equal in number, but opposite in sign, so negative 1,300 joules. Now, this is not delta H. This is just the energy that gets released when 25.7 grams of NaI dissolve. So what we need to know next is, well, how many moles is that 25.7? So to calculate that, we're going to need to do a molar mass step. So we have 25.7 grams of NaI. We're going to convert that into moles using its molar mass. And 1 mole of NaI has a molar mass of 149.9 grams. All right, so we do the math and we find 0.171 moles of NaI. So that's how much of the reactant we had for the process. Now, to calculate delta H is the amount of energy that gets transferred per mole, right? And in this case, because it's just a straight dissolving, we just put it over a plain mole, all right? So to calculate that, we need to know delta H is equal to Q, the energy that gets transferred, divided by N, which stands for moles. So in this case, Q is negative 1,300 joules. We're going to divide that by our moles, 0.171 moles. Right? We do our calculation and we find that 7,600 joules of energy are going to get transferred for every 1 mole of sodium iodide that we dissolve. That is our delta H. Let me know if you have any questions.